your science teacher broadcaster for Villanueva North Insider Science for Grade 6. Welcome back to another episode of Learning.
Almost everything around us is made up of substances that are physically mixed together to form a mixture. Most materials around us are mixtures. Some of them are readily found in nature, while others we make ourselves. Before we will formally start our lesson, let us read first our learning goals. After this lesson, you will be able to, number 1, compare solution, suspension, and colloids. Number 2, list the difference between solution, suspension, and colloids. And number 3, realize the differences of solution, suspension, and colloids and their use in daily life. How about a review first to check what you have remembered from our previous lesson? Are you okay with that? Okay, great! So here's the instruction. In the previous lesson, you have already learned the different kinds of mixtures. Classify the following mixtures as solution, suspension, or colloid. was your score? 10 out of 10? Wow! Good job! Solutions, suspensions, and colloids are kinds of mixtures. Have you ever wondered how do these mixtures differ? Come on, let's find out. Solutions are homogeneous type of mixture of two or more substances. A solution has two parts, a solute and a solvent. What is a solute? It is the substance that is being dissolved, while solvent is the dissolving medium. For example, in sugar-water solution, the sugar dissolved in water. Thus, in this solution, water is the solvent while sugar is the solute. Suspension is a heterogeneous mixture containing larger particles that settle out when left undisturbed. These are some substances that do not mix when combined. They just settle at the bottom or float on top. Substances like oil, soil, sand, and gravel do not mix when placed with water. They just settle out when left undisturbed. In order to distribute these particles evenly, the mixture needs to be shaken vigorously. A mixture of oil and water is a suspension. You can mix oil and water together and shake as hard as you like, but they will separate after some time. Here are examples of suspensions. Water and oil mixture. A medicine in suspension formula. A Christmas decor like a snow globe, and a mixture of water and soil. Colloids are heterogeneous mixtures with intermediate particle size between a solution and suspension. Colloid particles may be seen in a beam of light, such as dust in air in a shaft of sunlight. Unlike suspensions, colloids do not undergo settling. This is because the particles are so tiny that gravity has no effect on them. Here are examples of colloid: mayonnaise, paint, glue, jellies, and ink. Well, so much for the three mixtures. Today class is rather a special day for us. And why is that? Because you are going to meet an extraordinary man of science. We have been talking about his name for a while now, and I think it's about time that you all meet him. So, brace yourselves, ladies and gentlemen. I am honored to introduce to you our guest of honor, no other than Dr. John Tyndall. A round of applause, please. Thank you. Wait a minute. Who is he, by the way? What gives? John Tyndall, from 1820 to 1893, was a prominent 19th century British physicist. Tyndall effect, also called Tyndall phenomenon, scattering of a beam of light by a medium containing small suspended particles, such as smoke or dust in a room, which makes visible a light beam entering a window. The effect is named for the 19th century British physicist John Tyndall, who first studied it extensively. Here are examples of Tyndall effect in nature. So, the next time that you find yourself riding in your car and there's fogs everywhere, and when you look at the lighthouse, there's a beam of light coming through the fogs, and you know that is the Tyndall effect or the Tyndall phenomenon. Alright, it's time for a short break, and while you're having your snacks or perhaps doing your thing, I have something to show you. Please watch this.
Solution, colloid and suspension. Before starting the lecture, click on the subscribe button and get access to our 100 of conceptual lectures for free. Firstly, let me teach you that what is a solution. Well, a solution is a homogeneous mixture of two or more substances. So all homogeneous mixtures are solutions. Let me repeat it. All homogeneous mixtures are solutions. For example, when you dissolve salt in the water, you get a solution. This is also an example of true solution. And this salt solution, water has completely dissolved the particles of salt. Here, let me ask you, can you spot the particles of salt and water in this mixture? Well, you cannot spot the particles of salt and water in this mixture because both the salt and water particles are mixed in such a way that they form a uniform composition or homogeneous composition. Some other examples of solution are air, alcohol plus water, and vinegar. In air, different gases mix together to form a homogeneous mixture. Alcohol plus water mix together in such a way that they form a uniform composition or homogeneous composition. In vinegar, acetic acid is dissolved in water and they also form a uniform composition or homogeneous composition. Thus remember that a mixture is said to be a solution if its particles forms a homogeneous composition. Secondly, in a solution, the particles are so small that we cannot spot them with naked eye. Now, what is suspension? Well, a suspension is a heterogeneous mixture of undissolved particles in a given medium. So, all heterogeneous mixtures are suspensions. Let me repeat it. All heterogeneous mixtures are suspensions. For example, when we add mud or sand in the water, we get a suspension. Sand and water forms a non-uniform composition or heterogeneous composition. Because if we left sand plus water for some time, sand settles down at the bottom and a clear layer of water appears at the top. We can spot large particles of sand and water with naked eye in it. So it is a heterogeneous mixture or suspension. Some other examples of suspension are oil plus water, tea, and dust particles in air. In oil plus water, we can spot the layer of oil and the layer of water. In tea, we can spot small particles of tea and a column of liquid, while we can also spot the dust particles in air. Just remember that a suspension is a heterogeneous mixture in which particles are large enough and can be seen with naked eye. Secondly, if suspension is left for some time, large or undissolved particles settle down at the bottom due to gravity. Let me repeat it. If suspension is left for some time, large or undissolved particles settle down at the bottom due to gravity. Now, what is a colloid? A colloid is intermediate state between a solution and suspension. For example, consider some milk. We know that milk contains globes of butter fat suspended throughout the liquid. So milk is a colloid because the particles of milk are intermediate in size between those of a solution and suspension. Even if a colloid or milk is allowed to stand for some time, the particles of colloid or milk will not settle down. Some other examples of colloids are butter, jelly, ink. In all these colloids, particles are small and suspended throughout the medium. Secondly, these particles of colloid will not settle down at the bottom even if they stand for some time. Until now, we learned that a solution is a homogeneous mixture which forms a uniform composition and we cannot spot the particles in it. like salt solution. Secondly, we learn that a suspension is a heterogeneous mixture which forms a non-uniform composition, and we can spot the undissolved particles in it. Also, if suspension is allowed to stand for some time, its big particles will settle down at the bottom due to gravity. For example, sand plus water forms a suspension. While we also learn that the intermediate state of a solution and suspension is a colloid. The particles in a colloid are larger than those of a solution and smaller than those of a suspension. If a colloid is allowed to stand for some time, its particles will not settle down at the bottom. For example, milk is a colloid. Finally, let me teach you the difference between solution, colloid, and suspension. A solution is a homogeneous mixture, a colloid is a heterogeneous mixture, and a suspension is also a heterogeneous mixture. Secondly, in solution, the size of particles is from 0.01 up to 1 nanometer. In colloid, the size of particles is from 1 up to 1000 nanometer. In suspension, the size of particles is larger than 1000 nanometer. Thirdly, the particles of a solution do not separate on standing. Also, the particles of a colloid do not separate on standing, while the particles of a suspension separate on standing. Fourthly, the particles of a solution cannot be separated by filtration. Also, the particles of a colloid cannot be separated by filtration, while the particles of a suspension can be separated by filtration. Fifthly, the particles of a solution do not scatter light. The particles of a colloid scatter light, and this effect is used to distinguish a solution from a colloid. This effect is also known as a Tyndall effect. While the particles of suspension may or may not scatter light, but light are not transparent. This was all about suspension, colloids, and solution.
Welcome back to the Villanueva North Insider Science for Grade 6. I hope that you learned something from the video presentation from Najam Academy. To recap our discussion, let us now compare solution, suspension, and colloid. Okay, let's start with the particle size. In solution, the particle size is less than 1 nanometer. In suspension, it is more than 100 nanometer. Its particle is far larger than those of solution, so gravity is able to pull them down out of the dispersion medium or the water. And in colloid, the particle size of the dispersed material is between 1 nanometer and 0.1 micrometer. So technically, solution is small, suspension is large, and colloid is medium. Now let's move on to their appearance. Solution is clear because solution is always transparent, while suspension is cloudy because suspension are non-uniform in color and will sometimes look cloudy or murky. You will definitely see particles floating around in a suspended solution while larger particles settle down at the bottom. In colloid is translucent because of the Tyndall effect, which is the scattering of light by particles in the colloid. But other colloids may be opaque or have a slight color. I have a question here. Can you separate solution, suspension, and colloid by filtration? Well, in solution it is no, because the particles are very stable. In suspension, it is yes because the particles are of course unstable. Either these particles are floating or settled down at the bottom of the container or glass perhaps. And in colloid, it is no because the particles are of course stable. How about the effect of the beam of light? In solution, light may or may not pass through, considering that the mixture is uniform throughout. And in suspension, unless you will shake the mixture vigorously or maybe leave it undisturbed, it may scatter light or be opaque. And in colloid, the light is scattered due to the Tyndall effect. Okay, when we talk about uniformity, solution is homogeneous. Suspension is a heterogeneous, while colloid is a borderline. It's between a homogeneous or a heterogeneous. How about an example? Of course, the common example for solution is the salt solution, otherwise known as the true solution. In suspension, we have muddy water, and in colloid, we have an example of a mayonnaise. That's it! We're done comparing solution, suspension, and colloid. And now it's quiz time! This is a 10-item quiz, and here is the instruction. Read each item carefully. And this time, I feel so very generous because I will be giving you 10 seconds leeway for you to choose the letter of the correct answer. And please write it in your activity notebook. So, are you ready? Let's begin. Number 1. Which of the following liquids do not mix with water? A. Liquid soap. B. Cooking oil. C. Soy sauce. D. Vinegar. The answer is letter B. Cooking oil. Number 2. In solutions, the additive is called the blank, while the substance that dissolves the additive is called blank. A. Solute and solvent. B. Solvent and solute. C. Seasoning and water. D. Solubility and concentrated. The answer is A. Solute and solvent. Number 3. You prepared an orange juice drink by pouring 1/3 concentrated juice and 3/4 water into the glass. You found out that the mixture is very sweet and not good to drink. What will you do? A. Add more water to the glass. B. Add more concentrated juice to the glass. C. Transfer the mixture in a big container and add more sugar. Or D. Transfer the mixture in a big container and add more water. The answer is letter A. Add more water to the glass. Number 4. Blood is a mixture. What is it made of? A. Plasma and minerals. B. Blood cells and vitamins. C. Plasma and blood cells. Or D. Vitamins and minerals. The answer is blood is a mixture of plasma and blood cells. It's letter C. Number 5. An oil spill is one of the environmental problems that occur in the bodies of water. What kind of mixture is formed when oil is mixed with water? A. Colloids. B. Suspension. C. Solution. D. Saturated solution. The answer is letter B, suspension. Number 6. Which is the solvent in a cup of coffee? A. Coffee. B. Creamer. C. Sugar. D. Water. The solvent in a cup of coffee is letter D, water. Number 7. Which substance is a mixture? A. Oxygen. B. Tap water. C. Fruit salad. D. Carbon dioxide. The answer is letter C, fruit salad. Number 8. Cloud and fog are what kind of colloid? A. Liquid dispersed in solid. B. Gas dispersed in liquid. C. Liquid dispersed in gas. D. Gas dispersed in solid. The answer is letter C. Cloud and fog are liquid dispersed in gas. Number 9. Which of the following is not a solvent? A. Acetone. B. Paint. C. Gasoline. D. Water. The answer is letter B, paint. And the last but not the least, number 10. Why does sugar disappear when mixed with water? A. The particles of sugar are absorbed by the water. B. The sugar particles spread evenly in water. C. The particles of sugar becomes colorless. Or D. The sugar settles at the bottom. The answer is letter A. The particles of sugar are absorbed by the water. So, how did it go? Wow! Well done! You are amazing! I know you can do it! Thank you, my dear grade 6 learners, and I hope that you had a very enjoyable learning experience with me this week. Remember, this video lesson is created because you are all special to us. You matter to us, so better make good choices, okay? So that's it for today, and I'll see you again next time. Bye-bye!